right, so welcome Olivier and Yves Lange.
So hello, my name is Olivier. And,
my name is Yves. Hello. Hi.
And so we the screen stuff is going to be a bit tough because we have these three screens. We have to switch in between them. So
Close down.
where? Okay. So thank you for coming, and some of you who came by biking from the other side of the city. Thank you very much for being here. We're going to talk to you in about 45 minutes about web components. It's quite a tough topic actually, because when you pull web components, you very soon start to pull the web fundamentals. And although the web components themselves are quite easy to understand and very easy to reason about and very easy to use, the more you go, the more stuff that appears gradually. So presenting this in 1 hour is kind of a challenge. So we decided to focus on a primer, so to really introduce the technology and give some hints about where you can find more information. And we are going to show you in various live coding sessions how you can build a web component from scratch. We imagined this setup with many screens. Usually you will have here on the flip chart the summary of the presentation where we are, or sometimes previews of the live coding sessions. And then we have these two screens. The three of them are synchronized, so when we move forward, they will switch synchronized. So maybe I will get my screen because I don't have it. Voila. And well, maybe one thing worth noticing is that everything you will see here is web components. The presentation itself, it's all made of web components that are connected to Firebase in the back end, and when we switch the slides, it sends a little message and advances the head. So we're using Firebase here to synchronize. This we're not going to show. However, the whole source code of the presentation is available as a public repository. You will have the link at the end. And we even imagined a way for you to follow the live coding at this link, so you could open it on your computer and tablet. But this morning we are experiencing a bit network issues with Glitch, which is the live coding environment that we used. That because we have too many glitch sessions, and so we receive too many requests from them. So you can try, but I'm not 100% sure it will correctly work today. And that's it. Let's start. So the first thing we wanted to show you is that the premise of web components is basically that a web component is a little unit, self-contained, that brings you to the front end an application, a visible one usually, that you can simply pull in. And to use it, basically it's after you have imported a library that defines the component, all you have to do is use markup text and then discover the API of every component, because every component is a little world on its own. And so here you have an example of a quite evolved component, and this is also the interest of web components, is that when you want to use applications that are not trivial to do, web components are to show their strength, because you have this one, for instance, was developed by one of the guys from the Web Fundamentals teams of Google, and they spend a lot of time handling accessibility, compatibility with the AR environment, VR, and these kind of things. So when you pull such a component, you get quite clever functionality. And also the infrastructure that is behind makes it also very efficient. That means it will only load whatever it needs, which is also one compelling argument for web components. At the same time, and we will come back at this later on, you will see also that web components exhibit the same problem we have everywhere in JavaScript. That is, when you pull in a library, usually npm install means installing a hairball of thousands of dependencies. So when you start building things, it gets a bit more tough, because there you need to tree shake and enter the whole world of Rollup, Webpack, or any tool that you can use to do this. But for now, just to tell you, basically, once you have imported the library, this one is a self-contained library that we downloaded, so we got the full tree behind this. It's a bit heavyweight. However, once you imported it, you just have to insert such a markup and it's live. And maybe if you can show, it's really live. It's really a component here that you can move around. It also works with tap and touch. So voila. And the model here is about 2 megabytes. It's a standard GLB file that you can output from Blender or any 3D animation app. So it's a real use case of a 3D mesh and a complete mesh that you would export from a predictive application. So maybe enough for our. Voilà. And so now let's start maybe with the basis. What are web components? Fundamentally, web components are 4 standards by the spec. There is a link here, webcomponents.org/specs, that explains this quickly. And in the next slides, we're going to go over it quickly and also show you in the browser how it works. Maybe I tell it quickly. So the two first and most important standards that are being used everywhere are custom elements, which is a specification on its own, and there is a complete API in the browser that fulfills all the aspects of the specification, and the Shadow DOM and CSS, Shadow DOM and Shadow CSS, which brings fragments of DOM that can be attached to any element and that encapsulate the code that is there. And what is also interesting is that this encapsulation also contains CSS, and it scopes the CSS. So when you build web components, and more about this later, your CSS will only apply to the space in which you're developing, which makes it very, very easy to develop. And then there are two other things that have been quite shaky, and there are the templates, which per the spec is actually HTML templates, which is also an API. And you also have the whole question of modules and imports, but initially in the first version of the spec, it was HTML imports, so it would allow to use link tags with source and rel to import all your dependencies. But this has been a lot in flux, and finally the whole community abandoned this way, although the specification is there, but they abandoned it because it's a bit a complex discussion, but basically some of the browser vendors refused to go that way, namely Firefox in 2014, so already very early, and they told, please wait, first we have to make sure that imports work correctly in browsers, and once we have this foundation, we will see if we also put HTML imports, and this time we build it on top of imports. And this discussion has been raging for 2 years, and finally everyone decided to settle and abandon HTML imports for now. So now we are currently in a phase where all web components use ES6, so ES 2015, ECMAScript 2015 modal imports. So that's just an important thing to know, because you are going to find code on the web that is using HTML imports. So all the examples that we're going to give here are going to use ES6 modal imports, but just for you to know that this part here has been in flux. And templates also, Currently, you won't use actually the HTML template specification per se. You will use libraries because there is one now that is super efficient and that is replacing HTML templates. So also to know that these are in the spec, but in practice we use AS6 imports and here another templating system which we're going to show. And then also just for you to know, web components, it's also a word that wraps a lot of things. Some people, when they think about web components, they also think about these units of components. You take a web component from the public registry, and the whole package is also named a web component. And this is the registry I was talking about. Webcomponents.org exposes all the components that have been developed and published by the community. And then web components also is a kind of cloud of various notions. But what is very common also in the web components world is that there is a sound. People are very aware of the question of accessibility. And so generally web components that are well done by companies that really back them, they also make the effort to make them accessible. That means that every element within the component would expose its role and say precisely how it should be read if you're using a Braille reader, a Braille line or a text speaker. So this requires some effort, but it's a concern that is there. And another concern that is also quite widespread and understood by people is the question of the UX of the web components. And it has been very much popularized by the first components that were published, which are the material design components. Well, the material components which are of Google, which are implementing all the guidelines of the material design. And I don't know if you know about this, the material design. Do you? Yeah. so there's a website, material.io, which contains a booklet, which is a very, very complete documentation, which is kind of like ours, Guide du typographe, that we have here in Suisse Romande for people making graphism. In all graphic schools, you read this. So this is the equivalent for web components, which contains a lot of guidelines to make it easy to use in any circumstance. Yes?
Can you use this material
I didn't understand.
Can you use this material with the framework Angular?
Yes, so the material IO, it's a set of specification that is technology agnostic. And so there are implementations of the material design with jQuery, Angular, React. You will find for every framework material design implementation. And most of the components that are currently published on webcomponents.org that have been built with Polymer, all the paper elements, all those that are named paper, they will also implement the material design. Well, so just for you to know, and it's also a very diverse and open web community. Everything is discussed in the open. This technology is being supported by many actors, which are very close to the standards. So there's also, for everything that pops up, they will generally write a standard for the web and try to get it adopted. So the process of maturing of web components is very close to the standards, and it took years. Since we're following it, it's about 6 years. They have brought many little things, such as intersection observers, resizable observers, many things, async, iterators, and many things came from the world of web components and have been pushed as standards. So also for you to know, web components, it's also all of this, although these initiatives are also independent of web components. So enough for the fundamentals. Just to, well, the usual compatibility matrix. So for you just to know that these web components nowadays already run in more than 1 billion devices. Actually, Google find it so mature that 2 years ago they rewrote completely YouTube using web components. So if you look in the code source of YouTube on a page, you will see that the elements are named yt dash and then something. And these are actually web components, and you can explore them and look at them. So you probably already used web components without using it. Google Earth has also been developed with it, and many tools of the suite of the Google environment, how you call office environment of Google, the J suite. Okay, and so here I have written the different features of the web components that are required. Basically, you need ESSys classes, because you will see afterwards why. You need module imports, you need an implementation of the custom elements spec, and you need an implementation of Shadow DOM and CSS. And also, because it's very practical, you will very soon use CSS custom properties, which are kind of variables that you can define in your CSS at the root, and then using the syntax var, and then in brackets, you put the name of the variable you want, and so you can reuse that definition, such as the background color, for instance. You define it once on the top of your CSS and you reuse it everywhere. You find yourself using this very quickly, because sometimes within the components, you want to pull something that has been defined on top of you. So this is one thing you would like to use, and all of this is natively implemented in Chrome 66, in Safari 11.1, Safari that was released, and all these browsers were released between March and April last year, and the last one being Firefox in October this year. So you have a native implementation here, including on mobile Safari and Chrome Android. And then for Edge, you also have native support for classes, modules, and CSS custom properties. And for these two, we use polyfills from a project that is called Web Components.js, which completely emulates it, so it's fully supported. And even for year 11, you use polyfills, and year 11 has only ES5, so you also have to transpile your ES6 code to ES5. And then if you're serving E11 and the others, usually you find yourself making a differential build. So this is the part that gets a bit tricky. So you will build your project usually 3 times. One time for ES5, bundled with everything. One time for ES6, bundled with everything. And one time for ES6 with module support. And then you will need a server that is able to detect a feature of the browser and serve the correct build. And Polymer has a lot of tools to do this, so this is one way to serve a very large audience. If you're in a controlled environment, which is what we did in the 2 last years, we already knew what kind of browser were used. So in corporate space, usually you are either there, either in Firefox or in Edge, and so you know what kind of builds you need to do. Voila. And there's another matrix I just wanted to show here that, well, the web components polyfills I was talking about, they provide you full support for custom elements and Shadow DOM, and they're being actively supported. This is the contract they publish. They explain here the targets of their maintenance and support. So they are targeting all these versions of Edge. And it is the technology that enabled Google to switch for web components on YouTube 2 years ago already, and going really worldwide complete deployment. So this is the thing you can really rely on. It really works. So basically, in short, we're close to native everywhere, and then for Edge and EO here we have polyfills and full support, and for EO 11 you need a differential build. So this is a bit more work, but it works very well too once you did it. And then one last thing, you will also see in examples when you look for code, you will see also the latest syntax of ASCs. They will use class decorators, which are at and a property or things like this that will rewrite your code. This is supported natively nowhere, and you will always need either a TypeScript transpilation or Babel. You will need one of these 2 things and put them in your tool chain. So just to tell you, if you see class decorator, don't panic. It's supported nowhere. So either you have it in your tool chain or not. And if you don't have it, then don't use them. You don't need them actually. Voila, and and now maybe time for a little demo. Where's the code here? We wanted to show you quickly that custom elements are really, it's native, it's really built in your browser. You don't need any library to use it, nor do you need any compilation step. And to showcase it here, we're going to show you, do it live in the browser, just for you to have a feeling of what it means.
Okay, so let's go. I hope it works. I've got these always, you know. So here what we're going to do, we take the about blank page, so there is nothing. What we want to emphasize, as Olivier said, is that we have no framework, no libraries, so it's native. So I copied the previous snippet of code, and if we go to the console, I just paste it. So now I have an element here that is defined, and I can use it in my DOM. So if I go to the DOM here, I can use my element. Let's copy this also. And voila. So now the element is defined, it's connected to the DOM, and it appears. What we can show also is that we can reuse this element multiple times. So again, if I want to add it, let's say somewhere in my page, here we have nothing, so let's just add it here. And voila. Also the component is displayed here. What we can also see is that we have a shadow root, so that we'll talk about this a bit later. And this encapsulates the logic and the template and the style of the component.
Yeah, and so maybe let's show this example now, styling it. So which is the next example that I have that we have put here.
So I guess this is the snippet of code, and again the main difference here is that we added a style tag with the color of the div text. And so now I can use maybe this one. And here we have the new component.
The selections, so we can see it became green, and now open its shadow root here. So this is now a very important thing. This is one feature that I like a lot because it makes it very easy to develop components and reason about them. They encapsulate their own world. And when you define styles, then you're local in your component, and you just define style selectors for the DOM that you're actually putting in your element. And the interesting thing is that if you try to put a div element below body as an immediate child of body, yeah, maybe here, yeah, anywhere, and some text in it, you will see that this div won't be contaminated by the style that has been put in the shadow DOM. It's really, the style is scoped to the shadow root of the element. And so here, no color. And the same, if you try to add now a style element on top, maybe in the head or below the body or whatever, and you add here a style, and now you color the div in blue, let's say, or in red, whatever. Voila. Okay. So now we see that the last div has been styled by the close, the style that we did put here on top. And this style does not apply to the shadow root. It only applies to the div that is here. And within the shadow root here, we have a style clause that only applies to the div that is here in this style element. So you have a complete isolation between the custom element and the environment into which it's being used. the custom element has its own CSS and it only applies within this world. And what is being defined on top does not immediately apply. There is one exception. It's for properties that are being inherited by CSS. Some of them, such as font style or colors, they inherit. So, no, not color, but font, for instance. And those will traverse the complete DOM as for any element. So it's also possible to style the my style element here, and to, for instance, I suggest add a style here, selector, for the my styled element, or the my elements, and add some padding for them. And the background color, such as a light gray.
What did happen?
You call it the padding.
Yeah, I call it the padding. It's beautiful.
Bon.
Because we have div here, I guess that, okay, there is something weird.
Should work. Well, these are the joys of CSS development. Pourquoi il a fait un petit peu blanc? Bon, mystery. So remove the background and put some margin, and that's it. Anyway, so these are the notion shown here. Also to recap, so when you build custom elements, you can either build an autonomous element that is a completely new element, which is usually what you do, or this is currently in a flux, but just for you to know, you can also customize built-in elements and then extend their functionality. So for instance, if you would like to inherit from an HTML button element, you could do this and then customize its behavior. The advantage is that when you do this, you pull in all the behaviors already of the component. However, this is only supported by Chrome currently, and it's a bit in a flux. So what you will see everywhere currently are autonomous custom elements, but these custom elements, you need to build everything from scratch. And but there is a templating system to the help. And then, as you saw in the example, to define and register a custom element, you use custom elements.define. This is within the API of the browser. It's exposed on the window object, so it's in global scope. And you use the method define. You give the name of your element, and then you give the class that instantiates this element. And this class must satisfy to the interface of custom elements. But basically, you just need a constructor in it to start with. And then within the class, first thing you're going to do is attach a shadow DOM to your element, and then populate your shadow DOM with whatever you want. And this is what I was saying, the style information that is inside of the components does not apply outside, and vice versa. What is defined outside, to the exception of the properties that inherit, is not brought inside. Voilà. Next. Yes. Okay, and now a bit more on the shadow DOM. This is now a very important aspect. By default, an element, when it has a shadow DOM, it will, if you use it in the code and you put any children elements, by default it will remove them. So you can perfectly well take the code and put something into my element, and it wouldn't appear, it wouldn't be rendered. However, if you would like to design such a component, you can by using the slot tag, which you can put anywhere you want in your shadow DOM. And in this case, the children of your custom element, when you use it in a browser window, will be put into this place where you have the slot. And you can actually put many slots, not only one, you can name them, but this is a more advanced use case. Usually you have just slot, and you replace that slot with the content. So here, an example of how that might work. If you put it here, the console.
Yeah. So again, and now, of course, actually I can just add something. I can define the component, I can put the component initially in the DOM, and then I can define it.
Yeah,
so,
maybe show it.
So we can do it.
It's also interesting. And this is one of the topics that with web components, once you start using it, it's one of the topics that it's not complex, but it's a bit complicated, like every system where you have a life cycle. The life cycle of custom elements is quite evolved because you can do a lot of things with web components. You can imagine you can remove one element from the DOM by code and put it into another frame somewhere else. And so the component will be detached and reattached, but not reinstantiated. It was already instantiated so it's a weird use case. But just to tell you, the API supports all of this. So when you start to do clever things, suddenly you might find yourself needing to implement this. And this is one of the difficult bits, but it's basically like every component system. At some stage you can't remember exactly who gets the first, who's being called first, and so on. And so custom elements, you can use them in the DOM, you can use the tag in the DOM before it's being defined. And the browser by default will just ignore it. And then once you add the code and you define it, the browser will upgrade all the elements that were there, that had no effect, that had no functionality until they were defined. And once you define the code, then they get upgraded and bloom in the browser.
Voilà. But by the way,
Well, and now you edit the my header and you put some content. Exactly. So here an example of an element, and now Yves is putting some content as a child of the my header. And this content will now be inserted in place of the slot that you have here. So it will inject it into its own shadow DOM, and if you open the shadow DOM, you will see that this text appears again here. Well, it just shows the text. And this is of course just a copy of this element. So here it's the console, it's maybe a bit confusing, but what you see here is actually your DOM, what you defined while writing your code. And this part, well, it's this, so this is your DOM, and when you go back you see here the text. And this part is just a shadow DOM. And now it shows how the component is implemented, and it shows that it repeated this text here in this place, in the place of the slot. So you, and Chrome, to make it a bit less confusing, just tells you there's text here, and if you want to know where it comes from, you click on reveal and it goes there. Safari does it a bit different, but the idea is basically that this text was put by the browser in this place. And it actually just attached the node, so it's just reusing the same content. And so here you have an example of a component that you can completely customize. The component would every time allow you to build a header of an application. You give the current title of the page, and the component will bring all the features that are transversal that you want to reuse everywhere, such as a menu, for instance, will bring it for you.
So if you want to call directly a slot,
yes.
How do you do it?
Call? What do you mean by call?
For example, I'm doing JavaScript searching my jQuery $sign my header, and I want to get back just the
contents
slot.
of the slot.
Yeah.
Yes. So you have the API is super complete. You can reach everything that is in the shadow DOM. Basically, the principle is that within the component, you have the this keyword that is pointing on a class that is linked to the element. So when you write code within the component, you will say this to talk to the element itself, and then .shadow root, and shadow root will give you access to this invisible element, and from there on you can use a query selector or whatever you want to reach all the elements. And for the slots, you also have a little API. You can either use the slotted selector for query select, for instance, query selector. Or you can reach it directly by dot, I can't remember, dot slot something, or get slot. Or
yeah, actually you can do document.query selector, and then here what you can do is select your slot. I think the syntax is something
slotted
like
or
this.
slot, something like this. Slotted element.
It's an attribute actually.
But here you're in the document.
Yeah, but it works because it's a slot.
Ah, yeah?
Yeah. Else, if you want to go into the shell root, so
you would write this
instead of document.
Okay.
Voila. So this was to give you an overview of the native API, and just to show you that it works out of the box without any additional library. We didn't import anything. We just opened a blank window and started coding. So all of this is part of the fundamentals that we talked earlier. So it showed Shadow DOM, as well as the custom elements definition. And then, well, I won't go into detail. I just want to let you know that the custom element specification has a life cycle. There are different events that are being called, but in practice, you don't use this that much. Usually, you're working in a library like lit element, which has its own life cycle, and you will learn this one. And in some rare cases, if you want to handle the case of an element being detached and reattached somewhere else, or if you want to dispose resources because you have a heavyweight component like the model viewer that is using the 3JS library, maybe you want to dispose the meshes and so on, and so you would do this into disconnected callback to be sure that everything is being freed and garbage collected. But usually you don't use this, you just use the constructor. And then also lit element will provide you a lot more functionality about the attributes changed. So you can consider the custom elements API as a low-level API, and I just wanted to tell you they are there, but I never worked with attribute changed actually, and only connected and disconnected and adopted is a very rare case. But just to let you know, these are the 5s that belong to the foundation.
Maybe just a note and a tip if you begin. Don't forget to call super.constructor every time you call those methods, else it will not work.
Okay, and now to finish with the standards. I have nothing much here to add to what is written. The syntax we're going to show you in the live coding samples. There are maybe 2 things that are important to know, is that when you use ES6 modules, they're automatically in strict mode, which will make certain things not work, such as require package.json, for instance. It won't work because the browser will answer with application slash a MIME type of application slash JSON. And in strict mode, the browser expects you to deliver text slash JavaScript MIME type. So libraries that have been built with which do require package.json and then grab the version from there. For instance, these library, you will have trouble using it. And just to let you know, this is because the entire contents of JavaScript module are automatically in strict mode. And yeah. And then, as I told you earlier, HTML template. So there is a template element in the specification, but in practice, you won't use it. The idea of this template is just you can define whatever you want into it. It's being linked to the DOM, but it's not instantiated until you use it. So whatever you put in between 2 templates, being in video, audio, it won't load until you make an instance of the template element. But in practice, this is also low level, and it was very common in Polymer 2 to use this, but nowadays with lit element, we don't use it anymore. But just to tell you, it exists. And it's part of the fundamentals. Voila. So how far are we? Oh, already 12:50. Okay. Bon. Qu'est-ce qu'on fait? So now we wanted to show you an example of building an element, which is actually the summary that you have here, which is a component. And we wanted to show you how you would create it, render it, and then how you would link an attribute to it, and to change the currently selected entry of the summary. So maybe we need to go a bit quick here and show immediately the result.
So that's, I hope it will work. Let's do it like this. So basically, when we want to build an application or an element, component, sorry, what we're going to do is, first of all, the initial steps, so define the HTML document, maybe a style sheet, but to make sure that it works in every browser is the correct polyfill. What we want to do is to import this library, which is Web Components JS Web Components Loader. So this will make sure that if we use also a lit element, and if there are some browsers that doesn't support the current custom element, then it will codify some of the API and it will make it run for you.
So this is what I called the Web Components polyfills earlier. So this is the concrete usage of them. So either you have source equal /node modules, which means we have this library locally, and it's our server that is being serving it. Or you can also reach them out on your favorite CDN in unpackage or JS deliver or whatever. So instead of this, you would have HTTPS / and so on. And then basically you import here the source code of your element, which is what is coming next, which defines the element.
So this is the element that we want to upgrade. So let's go to it. Here. Okay.
And here now you have a very classical example of a lit element. So now we switch to a library that is called lit element. That is being developed by the Polymer team at Google. This team has been responsible for many of the evolutions of web components, and they have been working initially a lot on the tooling, on the tool chain, to allow to have a little server that can deliver modules and so on, to do the transcompilation, but they extended their efforts to many things. At some moment, at the peak of Polymer 2 years ago, it was doing so much everything that people kind of mixed Polymer and web components. They had the impression it was the same. And nowadays it changed a bit. They reduced their focus. They did focus on toolchain again, Polymer. They're gradually leaving Polymer 3 and they're going to lit element, which is also something that was developed in that team by one guy. And this lit element takes cleverly advantage of template literals from the browser. So it uses the browser to parse the templates, and then it substitutes the operations that are being done on the fragments of the template by the lit element templating library. And so you see such a template is being written as HTML backtick, and this HTML is actually the lit HTML, one library used into lit element that does all the heavy lifting. And maybe the important thing to tell there, sorry I'm accelerating, because there would be so much to tell, but here what you have to see is that basically in the code here of this component, the lit HTML class expects you to implement at least one method, which is called render. And this render has to return one HTML fragment that is being produced by this template literal. So you just do return HTML backtick, and then you write here whatever HTML you would like, including using other components. It's not an issue. And one of the main features it provides you is that it allows you to inject into these templates using the same syntax as Java as in your browser, variables that come from the context of the class. And there you would just write $, voilà, here. You would just write $ brackets, And then here use this whatever, or just a constant that you have defined earlier. You could write, yeah, this active, for instance, and it would write the value of this active at this place on top of the H1.
Also, you can use some expression, so it's pure JavaScript inside that. So you can basically write everything.
And here we see that this dot active is active, but it's yes, yeah, okay. It's actually the active elements. Voilà.
Yeah, it refreshed while I was like.
Okay. So what is active? It's showing us now the value of the attribute active index that has been defined on top of the element, and that is being exposed in the code through this property. And this is the second main feature of lit element. It does a lot of other things for you. The beauty of lit element is that it handles a lot of cases that are usual completely transparently for you. So you would write code as you would expect. And for instance, you can iterate over arrays, and just within such an expression that we had earlier, you could just use your array, do dot map, and then return HTML fragments from the map. And these fragments will be included into the other outer fragment, and so on. And so you can compose it to whatever level you want. It also handles asynchronous values, so you can also stream into a component, you can do quite clever things, and it handles this automatically for you. When it gets an update, then the template refreshes. And also, most importantly, it's super performant. They use the complete architecture of the browser. They delay the action, they debounce the changes on the properties and so on. They schedule it for the next micro task. And so it means also when you have huge trees, it works super well. And there are examples of the guy that worked this, that did this library where he builds a Sierpinski triangle with kind of thousands of elements that repeat everywhere, and then he changes one value and updates at once. And it does this with very little overhead for the browser. So it's a very powerful engine. Just to say, all of this is baked in, you have to do nothing. And basically what you do is define properties on your element, and then use these properties into your code. And the last thing to say about lit element is the way you define the properties. And so this is also a little API that is here, where you have, earlier we told you had to implement the render method. If you want to define properties, you have another method that you have to define, which is called properties, which you can define as a static getter. It's fine. So lit element will seek it as your class dot properties, and here you return an object with a definition of all your properties. And there is a little API that allows you here to declare the attributes. The idea is that all these, by default, all the properties you define there in the class definition will be reflected to, will have corresponding attributes on the DOM element that this class is linked to. And lit element does this for you for free. And here Yves is defining this attribute. It means that if you have another attribute defined on the class, on the code here, if you put here another attribute, voila, attribute, okay. So he used here a complex case because here we have a dash, and this is not allowed in JavaScript, so he will have to declare here which attribute this property is linked to. So here you have a complex example. And now the idea is that if you define this another attribute here in the DOM, lit element will detect the change, so it will observe the attribute. It will reflect the change from the attribute to the property in the class, and you, within the class, you just use this dot active or this dot another attribute. And you put it then in the render, in the render need to define them and you're in the
Yeah,
DOM.
yeah, sorry.
And you see all of this is live because now the component was mounted. Yves is modifying it in the DOM. So this will trigger a change. Attribute has changed. Lit element will catch it and reflect it to this property, and then we can use this property in return. And basically this is it. With lit element, you reach, you do almost everything just by doing this. And so you will wrap, you will hide all the implementation detail in your class, and the element just has attributes that are the API actually of your attribute. And now if you, I don't know if you saw when it changed earlier, the active index, maybe show this. When you go to the source code of the element, yes, and you change here for mele 2, yeah, enter. Here you have it immediately updated. Voilà. So here we have shown you at least the very basic minimum to start with. We are actually at the half of our presentation. It's noon, the pizzas are there.
Maybe you'll have to come back.
Maybe we should do another one, I don't know. Basically for this section, what we still had in stock was to show you how you will have two elements collaborating. This is maybe the last thing I can tell you. Est-ce que je peux basculer?
Ouais.
Là. Oh. I'm not in the right place. Where is it? Okay. Well. So here we prepared another example of a more complex element, which is a web component that wraps Vega, a little graphic. Vega is a very powerful engine that allows to build graphics. That is actually, it's called a reactive data flow computation graph. So it's a system where you describe link between values and how they should be displayed, and it takes a specification that is a little language, a little DSL that is super expressive and allows to do not only histograms but also geographic. You can display maps, for instance, and then have them react on your mouse moving all around it, and add layers, labels, and so on. And so we wrote one simple specification to make an histogram, and the values are coming now from Firebase, which contains a count here of who is on which slide, or who was on which slide. And what we wanted to show here is that is the way we fetch data, and once we get the data, maybe to make it very short, I just wanted to explain you the context, but the idea is we have one element here.
Sorry.
So we have one element here that is a bit a weird component. It's what we call glass components. That means they show nothing on screen. They're there. You implement them in the DOM. They will activate the class. It will activate all its features and behaviors. And this element, Firebase data source, will connect to Firebase, register to get updates to the data in live. And whenever it gets the updates, it will fire an event just to tell there is new data available. And it exposes this data in the event. And I just wanted to show you this because voilà. I told it for fun. It's kind of a mantra in the web components community. So there is this mantra that says you sync data into your components via the attributes, And then when the components need to communicate with the outside world, you would dispatch an event. And then whoever is around and has registered to receive the updates will get the data and react. However, there are other ways of doing this. You can, of course, target an element. Elements can, you can walk the dog, so the dog. You can walk the DOM and get whatever part you want in the DOM, and then send a message or call a method on whatever element you have in your DOM that you know that will answer to this method and communicate the data this way. So you can do it in many ways, but soon you will realize that you will need some method to do it, and it's a very powerful pattern to apply this. It comes with its own constraints because you have to register event listeners and so on, but it's a very sound foundation. And so communication in between components is handled by this principle. So we have here our Firebase data source, on which the page that uses it defines an event listener that says when you have data, then you call this little function, and this context, the page that is on top, will actually talk to the other element, our Vega histogram, and give it the data it received. And what is important here to see is that basically we're just actually to the property. We are just actually setting the data on the property data of the Vega element. So here you can assume that this Vega element that we defined, that is here, VCP Vega histogram, its class here has an attribute that is called data. And once you define it, the implementation of the class, as you saw earlier, will just react to the change and then inject it into the Vega specification, and the graph will update. So maybe, I don't know if you saw it changing, if you change the slides, normally, if I change the slides here.
If you change the slide there.
Here, you see it reacts. On me switching slides, take some notes. Here you see I'm moving backwards, and so you see it changing in live.
Yeah, maybe I think it's time is going, it's passing very fast.
Yeah, I'm sorry.
And we don't know what to do with it. No, it's amazing. Maybe we can take some questions.
Yeah, of course.
And wrap up for this time, and come back to give us a more in-depth talk about those components. So then anyone has a question, or in case no one has a question, I have one.
Yes.
A lot of this smells a bit like React.js. I don't know if you use it somewhere with a render cycle, and it's like a native React environment somehow.
We could really define it like this. It's actually native React. It's not React native.
No, exactly.
It's native React. You get the same API, the same concepts, the same principles, and just built in the browser.
And so, how much do you think it will at some point just
take over?
Take over, yeah. What is blocking?
I think one of the reasons is that is what I explained, is that you pull in a lot of the fundamentals. So when you start to look into the technology, you don't know where to start with. And then also it's not very well known here around. We also have people around us who are surprised that we use Polymer and web components, and they ask us what is it. We are actually using it in production since 2 years, and it's I really enjoy it because it's very easy to encapsulate things, and you soon make a complex system that you can easily reason about. And it's very easy to debug also, and very easy to use. And we have been very successful with it, being very fast, developing an application that work on many different contexts without doing much more. So the time it takes on, it's a matter of taste also of developers because it's another stack. And also maybe one of the things that make it a bit where now it's taking time to take on is that first Polymer is in flux. They have done a major rewrite of their library, and Polymer has been really the leading things. Earlier people would go to Polymer, and all the examples you're going to find on webcomponents.org are Polymer 2 and now Polymer 3. However, they're leaving it there. They made this effort for people to come to the latest version, but now they pivoted completely after all the experience they had, which is an absolutely incredible thing. First, but to make it short, just the thing is, you will find a lot of Polymer around, and they are actually pivoting it. So people don't know now where to go. And one of the things to know is that actually what they have officially announced on their roadmap is that they go to lit element for everything. So everything they're building now, they're using lit element and not the Polymer templating engine anymore. And then for the tooling, you still have a lot of Polymer, but people are unsure about what to use. And but there is one effort of the community to answer this problem, which is called Open Web Components, and they're making a lot of quality work. It's not a standard yet, but I guess because it's getting a lot of traction and support of many influential members, so I guess this part, Open Web Components, will give hints on where to land today. And the last thing that is a bit difficult with web components is that you use AS6 module imports, and many of the libraries that are out there, when you do npm install, you find yourself a super library, and you find that they're wrapped into AMD or universal module definition wrappers. They all still have in mind this isomorphism between Node.js and the browser, and so they try to require work on both sides. But now we have another system with the HTML imports, and when you use the HTML imports, very often your libraries, they don't implement it. And so if they use the wrapper, for instance, it references the global scope, where it looks for something that does not exist, so your library doesn't load. So you find yourself looking painfully, would they have made a module build, and if no, then you open an issue in the repository. So this is maybe also one thing that makes it a bit difficult to adopt. It's one of the points I noted here. In the difficult bits, it's this part. You will soon run into one such thing when you start working with other libraries.
Any question?
No?
Well,
Pizza time?
Yeah, I think so, yeah. Thanks a lot. So it's not web components, but some more Swiss components. As usual for the speakers, big bars of chocolates.
Wow.
Thanks a lot for presenting this amazing setup. I'd like to remind you the 9th of April, we'll have a meetup at 7 p.m. So for the night, a co-meetup with WebMardi and the Geek Girls Carrot. So please join us. It will be an amazing night with a lot of people, also a lot of time to socialize and and have good talks. So please join us. And Olivier and Yves will be around for some time now, probably around the pizza. So if you have any questions that you don't want to ask in public, feel free to approach them. Thanks a lot. Thank you very much. And please, pizza.